Welcome to Brain Vision.
Problem 11.69. We want to figure out what the maximum weight is that you can hold in this situation that was set up in example 11.4. We want to express this as a function of the maximum tension that the tendon can sustain, and LD and H. And our expression should not include this angle theta. And then the tendons of different primates, it says, are attached at different values of D. And it wants us to calculate the derivative of the maximum weight with respect to D, and then say whether it's positive or negative, and then use this to explain why chimps are stronger than humans, given that this tendon is attached further from the elbow for them. So, to begin with, a free body diagram is always helpful. So if we imagine this is our forearm here, we have some forces at the elbow joint. We have the tension in the tendon, is at our angle theta. This distance is D. The weight is acting over here. The whole length is big L, and then the height to the attachment point in the upper arm of the tendon is H. So, and that's the distance from the elbow to point B here. So now, if we want the torque to sum to 0 at the elbow, our condition for equilibrium, then the weight times the whole length of the arm minus the torque that the tension in the tendon exerts, which is T sine theta times D. So this has to be 0. We don't want theta in our expression. However, just using some basic trigonometry, we can see that the sine of theta is going to be h over the square root of h squared plus d squared. It's the opposite and hypotenuse. So, W is equal to the tension times h times d divided by the square root of h squared plus d squared. And so if we want the max, we just write max on the weight and the tension. And there we go. Now for part B, we just want to take the derivative of this with respect to D. And so this gives us just for brevity, we'll write m for max. So then this is equal to the maximum tension times H divided by L. Oh, I forgot an L in the denominator here. Sorry. Got kind of messy. Anyway, so L times the square root of H squared plus D squared and this will be multiplied by 1 minus D squared over H squared plus D squared see, this is just the chain rule and product rule, power rule, etc. Just, apply it appropriately to calculate the derivatives. And we can see that this is always going to be greater than 0. The only thing that could make it negative is this term here, because we're subtracting this from 1. So if this could be greater than 1, then it could be negative. However, we have d squared being divided by d squared plus something that's positive. So this is always going to be less than 1. And so this whole thing is always going to be greater than 0. Now, so then the reason that the chimpanzee can be stronger, given that its tendon attaches further from the elbow, is that as the maximum weight increases. That's what it means for the derivative to be positive, that your function, in this case the maximum weight, increases as the variable that you're taking the derivative with respect to increases.